Hello, so we'll be taking grip task 6 of data science and business analytics. So today we'll be analyzing and building model on Iris dataset. So Iris is basically a flower species, and we'll be doing a little bit of analysis, and we'll visualize, and we'll build a decision tree model on it. So firstly, we'll be importing libraries. So we are importing 4 libraries: pandas, numpy, matplotlib, and seaborn. So pandas and numpy are for analytics, and matplotlib and seaborn helps in visualizing data. So we'll be importing it. It will take a little while, and then we'll be reading data. It is CSV, and we'll be seeing the first 5 observations. Yes, so we have got 6 columns, 6 variables: ID, sepal length, sepal width, petal width, and species. So as we can see, ID is of no use, as it's basically the observation number, or we can say a row number. It's basically a serial number, so it's of no use. We'll be dropping the ID column, and we'll check the info. So we have got 150 entries, and all are non-null. And as we can see, species is object, it's a string basically. So let's see how the statistic part goes with the 4 variables. So as we can see that standard deviation 0.82, and mean 5.84 for sepal length we are talking, and medium 5.8. And if we see the data minimum number and everything, we can say yes, data seems to be, not exactly normal, somewhere near to normal. Same goes for sepal width, but with the data given, we can say it might have, a little bit of outliers maybe, because yeah, given the points, we can analyze it little bit. Like we have got 2.8 at 25% and 3.3 at 75%, and we have got yeah, so, and we have got maximum values 4.4, so it, and minimum to be 2. So we might have not a lot, but we might have like 2, 3, or 4, like near about what do we say, outliers. And petal length and petal width seems to be good. So we'll continue with the correlation part. We can see that sepal length is has got a positive and a good linear correlation with the petal dimensions, whereas sepal width has got negative correlation, but not like too high negative correlation, but yeah, it's fairly, negative linear correlation with the petal length and petal width. While petal length and petal width are highly linearly and positively correlated to each other. We have a 96% correlation. So let's see how many species do we have, and how are they distributed. So we can see that we have got 3 species, that is Virginica, Setosa, and versicolor, and all are like equally distributed, 50 observations for each. So now we'll be visualizing how the 4 numeric variables are actually has got relationship with each other. Though we have plotted a correlation plot, let's see how it works through scatter plot, and we'll be actually differentiating it with 3 kind of species. So we can see we have given a color thing to them. So we can see, yes, here this is a scatter plot, and we can see that Setosa is, significantly different from the other 2, versicle and virginica. And we can see, yes, Setosa has got low of both petal length and petal width, while versicle and virginica have got, higher petal length and petal width. And it like kind of similarly goes for all plots, that Iris Setosa is like, significantly different from the versicle and virginica. We might also infer that versicolor and virginica might have got some similarity between them, not like highly similar, but maybe a little bit of similarity they must have got with each other. Now, let us see how the individual numeric variables are actually different, like how they're acting for the different species. So we can see, yes, Irisatosa has got the lowest of petal width, while Versicolor and Virginica share a little bit of similarities. And we have also got a little bit of outliers for Setosa. And similar for length, while we can see that in case of sepal width, Setosa has got higher width, and maybe we can say 75% of its like 75% of data has, no, not 75, like we have got a higher, whereas versicle and virginica has got lower sepal width dimension, but Setosa here in length has got the lower compared to both. Now we'll be dividing our data into dependent and independent variables. So independent variables are here, of course, the sepal dimensions and petal dimensions, whereas species is what we have to identify, what we have to predict is we are keeping it as y. And we'll be importing necessary libraries, train and test split decision tree classifier. So first we'll be splitting data into train and test, and we are keeping test size to be 30%. Here we are fitting the decision tree classifier to our training data, and then we are predicting it how it is working with the training data, and so we have got like 100% accuracy here. Now here we'll be visualizing the decision tree, how it is actually built. So we have imported the necessary libraries, and then we have made we have given command to write a dot file, and so here it goes like filled is equal to true for our cells. The leaf nodes that will be there in the decision tree will be filled with some colors, and rounded is equal to basically means it won't have edges, sharp edges, but round edges. So here we are doing that. So okay, here because my environment is not the default environment in which I'm working, I've downloaded GraphVis in some other environment, and so I'm giving command for that particular environment. And then here we are actually giving the command to change that dot file to the png image file, and then here we have got this image, and we can see like here Setosa has been, on the basis of petal width, Setosa has been we are able to distinguish Setosa at first place, and then we go on for others and so on, and we can see, yes, with like we can say 6, yeah, with the 6 branches we can see that we are able to distinguish between 3 species. And let's see how the testing data works with the decision tree model. So yes, it works pretty well. We have got 98% accuracy, where we can see with the confusion matrix that only that one observation which was supposed to be versicolor was predicted as virginica. uh, yes, so there is that default, so there we have gone wrong, but our model works pretty good. Maybe with the more data model where it gets to learn more data, it will work well, but here we have got the mistake only for one observation. That's it, we are done with our Iris dataset. Thank you and have a nice day.